Good morning. So I hope all is well with you guys. We are going to start by reviewing all three forms that we've learned this unit, and then we're going to get into writing equations given information. So let's warm up first. When you look at each of these problems, you want to ask yourself, what form are you looking at? Is it, so you have a couple options. Is it standard? Is it vertex? Or is it intercept form? Those are the three options you have. So you have to see what you're given. Looking at number one, pause and think what form it is. You should have said vertex because you can clearly see the vertex in this equation. Now we know in vertex form, you take the opposite of the value next to the x. So instead of +1, it would be -1. And what's being added, you leave as is, so +1. The axis of symmetry, as always, comes from the x value of the vertex. So that's x equals -1. You have to first decide if it's a minimum or a maximum. So we know that the a value, if it's negative, the graph opens down, and therefore the vertex is a maximum. So we're going to circle max, and it will always occur at the y value of the vertex. So in this case, I'll use another color. The y value of the vertex is 1, so your maximum value is 1. The domain for these parabolas is all real numbers. And the range also has to deal with the y value of the vertex. Since it's facing down, we know all the y values are smaller or less than or equal to the y value of the vertex, 1. Okay, just some other info. Usually when it's in vertex form, you can clearly see the transformations of the graph from the parent, x squared. So in this case, the vertex tells us it moves or shifts to the left 1 unit. It shifts up 1 unit. It reflects because of the negative a value. And it's over the x-axis. And you can even say, since 2, the a value is larger than 1, ignoring the negative, we know it's a stretch. So stretch by a factor of 2. All right. The next one is in standard form. You have your a, your b, and your c. So a equals 1, b equals 2, and c equals -5. I'm going to say that's standard form. The vertex comes from the equation x equals opposite of b over 2a. In this case, the opposite of b is -2 over twice times a, which is 1. So x is equal to -2 divided by 2. That should give you -1. That is also your axis of symmetry. So let's fill that in first. And now we're going to find the rest of the vertex. To find the y value of the vertex, we plug -1 into the function. So I'm just going to show my work down here. And you're going to get 1 minus 2 minus 5, which will give you -6. And that goes in for the y value. Okay, minimum or maximum. Decide, does the graph open up or down? Does this parabola open up or down? So since your a value is positive, we know this parabola opens up, and therefore the vertex is the minimum of the graph. And it is at a minimum of the y value, so -6. y value of the vertex. The domain, again, all real numbers. And the range, again, deals with the y value of the vertex. Since it opens up, all the y values are greater than or equal to -6. Just some other easy information from this graph. Whenever it is in standard form, your y-intercept is very easy to see. It's the c value. And we always write the y-intercept as a coordinate. So 0, comma, the c value, which is -5. Okay. Last but not least, whenever it looks like it's in factored form, we know this is intercept form, where you can clearly see the x-intercepts. The vertex comes from finding the x-intercepts first. So what we're going to do is ask, okay, if these are my factors, then the opposite of these numbers give me my x-intercepts. So in this case, the opposite of -4 is +4, and the opposite of +6 is -6. So when you write it, write out the intercepts, and I'm going to write that down here. These are the x-intercepts. It's always the number, comma, 0. The x value, comma, 0. So now we use those values to find the vertex. The vertex's x value, which we know is also the axis of symmetry, comes from adding these two numbers and dividing by 2. So here's the math up here. 4 plus or minus 6, all divided by 2. And we get -2/2, which is equal to -1. So in this case, the x value of the vertex is -1, and the axis of symmetry is x equals -1. To find the y value of the vertex, just as you would in standard form, you're plugging this value back in for x. So in this case, y equals -1 minus 4 times -1 plus 6. And you end up with -5 times 5, which gives you -25. Is it a max or a min? The number in front is technically +1. Since it's positive, we know it opens up. And if it opens up, we know we're looking at a minimum value for the vertex, and the minimum comes from the y value. Domain is all real numbers, and your range is y is greater than or equal to -25. Okay, so that's a quick review for all of the forms of a parabola that we learned this unit. Now we're going to take information that we're given and create an equation. When you are given information for a quadratic equation, you have to ask yourself which form is the easiest to go to from what I'm given. So you read the information that's given and you choose the form that's going to be easiest. When it says satisfies the conditions, you just have to make sure you use all the information they give you. So let's look at the first one. Write a quadratic of a function whose graph satisfies the condition that the x-intercepts are -1 and 5. We know that when we're given x-intercepts, we're thinking, okay, that's intercept form would be the easiest to get to. We know intercept form using the x-intercepts is just writing it in factored form. So in this case, it's going to be 2 sets of parentheses. They don't tell us anything about a stretch or a shrink. We have x and x, And the opposite of our x-intercept goes inside. So here we're given -1, inside would be +1. Here we're given 5, inside would be -5. And that's it for part A. Part B, or question B, they give you the vertex. So now, okay, I'm thinking this is vertex form, which, just to remind you, is y equals a times x minus h squared plus k. The vertex, or your h and your k, are given, and that's what goes here and here. The a value, they don't give you a value, a stretch or a shrink, but they tell you this parabola opens down. So a has to be less than 0 or negative. So now let's begin to substitute our values in. Okay, y is equal to, a can be any number as long as it opens down. We just know it has to be negative. I would stick to something easy, just a -1. We know x goes inside, and your h value goes in as the opposite of what you see, so +3. And your k value stays as is, -2. That is a quadratic function in vertex form, and it satisfies these conditions. Last one. We are given 2 coordinates. What kind of coordinates are they? Well, I know that when we have a number, 0, we're looking at x-intercepts. If I'm given x-intercepts, I'm thinking intercept form. They also give us a little information about the a value. So when we write these in, we have our 2 sets of parentheses, and we're even given an a value we can put right here because it's stretched by a factor of 3. Inside we have x and x, and since we know that x is -9 and x is -2, the opposite of those values goes inside, so +9 and +2. Okay, I'm going to have you guys in a moment try these on your own. Let me see. Yeah, I'll have you guys try the next part on your own. So I would pause the video, and then I'll go over them in this video. So try it on your own again, and then watch. Alrighty. So in this case, we are given x-intercepts of -1 and 2. And it opens down. So again, x-intercept, intercept form. Since it opens down, the a value just has to be negative. I could even put a -2 there. Could be -5, -1, anything. Usually we just pick the easiest value if they don't give us a stretch or a shrink. Inside, x and x, opposite of what you see, +1 and -2. Here they give you vertex form, or they give you a vertex so you know it's vertex form. They give you a shrink so you have an a value. So in this case, your a value is 1/2. It's always going to be x, opposite of your x value, -3, and plus or minus k. In this case, it's -1. And lastly, your intercepts, or your x-intercepts, are -5 here. It's a +5. And so we know when we set this up into intercept form, it looks factored. Nothing is given about our a value, so it's just the x-intercepts. What goes inside is opposite. Okay. Last part, we're kind of just going to review a word problem, and I'm going to show you guys an easy way to answer some of these questions. We discussed these before school closed, so you should have a little, you should remember a little bit of it at least. But this is talking about a ball being thrown up in the air. Its height and feet after t seconds is given by this function. It represents the height. So when we go through this, if you have the graphing calculator downloaded, or you have a graphing calculator, the problem can become so much easier for you. There's a lot less tedious math involved, so I suggest you do that. So the first question they ask us is, what's the initial height of a ball? So let's just look at a visual real quick. This is not the calculator you should have downloaded. There's one on your computer which is much better and you have much more features. But we know we go to y equals, which is right here. You type that equation in, which I have already, negative 4x squared plus 24x plus 220. You can hit second, or sorry, you don't have to hit second for this. To see the graph, you just hit graph. And there's my graph. Can't really see what's going on here, but we know it's a parabola. It's being thrown up, and that top, that vertex, is the highest point of the ball, and then it falls, and when it hits the ground, it's technically hitting, see this, these are very big numbers. I probably missed it actually. Yeah, you're hitting the x-axis when the ball drops. So just to draw the picture over here, here's what's happening. Ball's being thrown up from an initial position, maybe it's from the top of the building, hits the maximum point, and it falls. If I continued the parabola, it would go over here. However, we don't look at negative values when you're throwing a ball. You're looking at positive heights. So really the only part of the parabola that matters is up until there when it hits the x-axis. Anything negative is irrelevant in this problem. Alrighty, so first question, what's the initial height? Well, we know the initial height comes from the y-axis. That's where the ball started, and then it gets thrown up and falls down. So we're trying to ask ourselves, okay, well, what's the y-intercept of this graph? Or what is y when x is 0? We know in standard form it comes from the c value, so in this case it's 220. But we want to write a sentence. The initial height of the ball, careful with units, they're talking about feet, so is 220 feet. So maybe it's being thrown from the top of the building. Okay. When does the ball reach the maximum height? Remember, maximum refers to, or even if the word was minimum, you're thinking vertex. It's the vertex of my parabola. So in this case, they don't use x. You could put x to show your work. They're using t in this case. So technically t is the opposite of b over 2a. You could put x if that confuses you. In this case, that's negative 24 over 2 times negative 4. And you will get, when you simplify this, 3. So if I actually had my vertex here, it'd be 3, comma, and then to find the actual maximum height, you want to plug that value in. So before we actually answer part B and C, let's just find the vertex itself. When you plug 3 into your equation, and just to show the work, this is what you're doing. You're going to get 256. So that would be the y value of the vertex. We know anytime the problem asks for maximum or minimum, you have to know what represents x, what represents y. Well, in this case, t seconds is your x. So this is your time, how many seconds. We know that your y, or h of t, is representing the height. So now answering part B and C makes it easier. You just look at the vertex and identify the part that answers the question. For part B, we got 3 for the x value of the vertex. That means it takes, or it will reach the maximum. I'm just going to erase this. After 3 seconds. And now what is the maximum height? Well, that's the y value of the vertex. So we say the maximum height is 256 feet. Anytime it asks for max or min, you're thinking, okay, let's look at the vertex and understand what part of the vertex represents what. Okay, part D. When does the ball hit the ground? Okay, let's look at the graph. What is ground level? Here's my x-axis, here's my y-axis. The ground level in this case is 0. That's the height of the floor. It's at 0 feet. So we know that means that y is 0. So if you were to do this mathematically, I'm going to show you how to do it with a calculator. You would set your function equal to 0. And then this part wouldn't be fun. You'd have to factor this. You would have to factor out a -4, that's your GCF, and then find factors of your C value that add up to your middle value. It just takes a lot of time. So here's how you do it with the calculator. I'm trying to find out, when is my height 0? When is this ball hitting the ground? So when you graph this in your calculator, you type your equation into y equals, which we already have. You hit second graph to see the table. And okay, so here's my x and my y. When is y 0? So you're going to scroll through. And I think I typed something in wrong, probably. -4x squared plus 24x plus 220. Nope, it's fine. Okay, so when is y 0? Well, here it is right here. That means my x value is 11 when y is 0. So I go back here and I say, okay, I found on the table that y was 0 when x was 11. So in this case, when does the ball hit the ground? After 11 seconds. And that's it. It avoids a lot of mess when you have to factor this problem. Okay. Hopefully that was not bad. Make sure you submit these notes on the Google Classroom. I'll make a submission post, and have a good rest of your day.